Okay, now let's have a look at the partial fractions. Now, if we got the algebraic fractions, we cannot integrate these ones. So we need to convert that into simple partial fractions, and then we can integrate these partial fractions. So the first step is to convert into partial fractions and then apply an integration technique. Why is that? Because when we got 1 over x, the differential integral of 1 over x is ln x plus a c. Yeah. Now, if you have a look at this bit, just the bottom bit, this is x cubed plus 2x plus 1. What? Not the integral. What's the differential of the bottom bit? If I differentiate the bottom bit, that will become a 3x squared plus 2x, isn't it? And you see the differential of the bottom bit is on the top. And if that kind of question comes up, I don't have to go through all the steps. I can straight away say, oh, because the bottom bit has a differential on the top, the answer is going to be ln of the bottom bit plus the c. That is the rule. Yeah. So, for example, if I go on the next one, let's say I want to integrate, let's say x5. Yeah. What's the differential of the x5? 5x4, isn't it? If I got 5, if this thing comes up, you can see the bottom differential is on the top. You don't have to solve. Just write down ln x5. That's the answer. X to the power 5 plus obviously a c. Because the bottom differential is on the top. Now, next thing is the degree of the polynomial. Is the highest power of the x that appears. If it's x cubed plus 7x squared, the degree is x5, x cubed. So 3 is the degree. Now let's say we got that equation. X, 2 minus x, x plus 3. Now I need to convert that into partial fractions. To do that one, I'm just going to write down a over 2 minus x, b over x plus 3. Once I got that bit, what I need to do is, I need to get rid of the denominator. How I'm going to get rid of the denominator? I need to cross multiply. So this x minus 3 comes here, and that becomes a times x minus 3. This 2 minus x goes here, and that becomes a b times 2 minus x. And they both multiply, which comes here. So on this side, I will have x on the top, 2 minus x, x plus 3. And that's equal to that one. Now, if I have a look, they both are equal, so the denominators are same. So I can cancel this denominator and that denominator. And I got x equals a, x plus 3 plus b, 2 minus x. So once I got that one, I can actually multiply these things in. So that becomes a times x, which is ax, a times x, which is ax, a times 3, which is 3a, b times 2, which is 2b, b times minus x is going to be minus b. Yeah. Now this bottom and bottom, they already gone. So you can just cross these bottoms. Okay, so they already gone. Now, then there's a thing called matching the coefficient. If you have a look here, ax minus b, that is ax minus b, x, the x is common. I take the x out and I'm left with a minus b. Plus 3a plus 2b, which is here. Why I need to do that one? Because then I will match the coefficient. What's the coefficient here? It's 1. So which means a minus b is equal to 1. So a minus b is equal to 1. Because why? The only thing, this whole thing is equal to each other is if the coefficients are equal. Now we need to match the coefficient. Now there is x plus 0. I can add 0. a minus b. So which mean a minus b should be equal to 1 because the coefficient of x is 1, and 3a plus 2b should be equal to 0 because that's a constant. So I just make the match the coefficients. When I match the coefficient, that will give me a equals 1 plus b. So that's a plus b, 1 plus b. And that's one of the equation I got. I'm going to call this one equation 2. Then I got another equation here. I move the 2b on the other side. So 3a is equal minus 2b. Just going to rub that one and do again better. So 3a is minus 2b. So a is minus 2b over 3. I divide that by 3. Now once I got that bit, that's the value of the a. I can put this equation instead of here in equation 1. Instead of a, I put 2b over 3. I put 2b over 3. Now I can solve this equation. So the way I can do is I can multiply everything by 3. So that becomes a 3 plus a 3b. I move this 3 on the other side, equals minus 2b. Now I move the 3 here and the 2b here. So that's a 3b plus 2b equals minus 3. I move the minus 3 here. That becomes a 5b. 5b is minus 3. So then b is minus 3 over 5. I just got the answer for the b. Once I got the answer for the b, I need to find the answer for the a. To find the answer for the a, I write a equals minus 2 over 3 multiplied by b. b is minus 3 over 5. Now the 3 and the 3 cancel. The a is 2 over 5. Because there was a minus here and a minus here, that makes that thing. So I got the value for the a and I got the value for the b. Okay, now we got the value for the a, which was 2 over 5. So instead of a, I put 2 over 5. 2 over 5. And b was minus 3. So minus 3 over 5. So I got these two values. Now I need to integrate this thing, which was in fact that thing was reduced to this thing, which was reduced to that thing, and which was reduced, we got the value for a and the b, to this bit. So if I integrate that bit, which is same as integrating the original question. So now I'm going to integrate it. Integrate 2 over 5 2 minus x I'm going to integrate them separately. Minus this minus is that minus. Integrate 3 over 5 x plus 3. Now the rule for the integration says, let me delete this bit. Just gonna do from the scratch. Okay. The rule for the integration says 2 over 5 comes out, and I have to integrate that thing. 1 over 2 minus x dx minus 3 over 5 comes out, 1 over x plus 3. Once I got that thing, I am going to use my ln thing. If you have a look at that one, what's the differential of this 2 minus x? Differential of 2 minus x is actually minus 1. So, but there is a 1 on the top. So I need to make it minus 1. But I can't just make it minus 1. I have to, if I put minus, I have to put minus here as well. What's the differential of x plus 3? Differential of x plus 3 is just 1, which is on the top. Once I got that one, I will proceed to the next step where I can use my ln thing. Now, once I got this thing, I need to integrate. Now, according to the law, the integration of that one is minus 2 over 5 already there. The differential of the bottom exists on the top, so it's going to be ln of 2 minus x. Minus 3 over 5 is there. Integration of that thing exists on the top. It's going to be ln of x plus 3. Do not forget this plus c at the end. And this is the answer. There are some practice questions if you want to try here. If you want to go over these practice questions. So they're all there.